Hello everyone, welcome to Sunya IAS and welcome to this lecture. In this lecture, we are going to talk about the composition and structure of the atmosphere. Very important topic. I'd say every year you can expect a question directly from this. This is that important a topic from which you can expect a question every year, and a question can also come in lieu of environment also, because the pollution of the atmosphere, right, the accumulation of, let's say, the ozone destruction, all of these things, they can be clubbed under environment also, under geography also. So please pay a lot of attention on this particular topic, and we'll start. Let me just brief you about this particular course that we are running, which is Revise Entire Prelims Syllabus through 3000 plus MCQs, wherein we are doing modern history, polity, geography, economy, art and culture, current affairs, ancient medieval, environment, ecology, and science and tech. So all of these things we'll be doing. We have already done Indian polity, we have done modern history, and we have done Indian economy. We are now doing geography. And the purpose is to make you very accustomed to solving questions, UPSC new pattern based questions, and so that you can be confident there. So we have already done about 1300 questions by now, and we are going to do a total of 3000 MCQs. So you can contact on this number, visit this website to know more about it. And this course we have made extremely affordable, so that there is no problem for you to go ahead and purchase this course, so that you can get the PDFs in advance and detailed explanations also in advance. All right. First question. Consider the following. And since we don't have a question, we'll move to the question first. And then we'll read the options. Which of the above are the major natural sources of gases building in the atmosphere? So, volcanic eruptions, degassing, meteorite impact, climate change, vehicular emissions, and photosynthesis. So, इसमें से क्या क्या natural reasons हैं? ठीक है. So, हमें let's just click the obvious first. Volcanic eruption से we know that gases are released. Degassing, it is it's a process by which the gases from inside the earth, they were released into the atmosphere, and then the whole crust was formed and everything. So even this is the release of gases, and it contributed to the atmosphere building. Then meteorite impact, basically when a meteorite hit earth, because of which they say that the dinosaurs got extinct, etc. So that meteorite impact does lead to release of gases, right? Even various noble gases are released when a meteorite hits any planet. So third is also correct. Now climate change is considered an anthropogenic source. So because of climate change, we know that carbon emissions and carbon in the atmosphere is increasing overall, but we still consider it as an anthropogenic source only. Fine. Then we have vehicular emissions. Of course, vehicles are not a part of nature, so they are anthropogenic again. And photosynthesis. Photosynthesis will release oxygen. In fact, the first photosynthetic bacteria, which was the blue-green algae, cyanobacteria, they contributed to the creation of oxygen in the atmosphere, right? So here photosynthesis will also be a part of it. So 1, 2, 3 and 6. These are the options. Now 1, 2 and 6 could have been a probable option, because you would have been confused that whether a meteorite impact will lead to gas emissions or not. But it will lead to gas emissions, and in fact when the meteorite hit, which is the theory that we follow, in fact the Lonar Lake, I'll tell you, the Lonar Lake in Maharashtra is said to have formed because of a meteor impact only. Fine. So when a meteor does impact us, it does release a lot of gases. ठीक है, तो यहाँ पे 1, 2, 3 and 6 would be the answer. Next पे चलो. What is the main source of energy for Earth's atmosphere and weather systems? Tidal energy, solar energy, geothermal energy, or kinetic energy? So for any other energy to work, the primary energy has to be solar energy. ठीक है, without solar energy, tidal energy will not work. Without solar energy, there will be no let's say hydroelectricity that could be made. There would be nothing which would function, because when solar energy comes, the temperature differences arise, and temperature differences actually lead to wind blowing, temperature differences lead to ocean current, temperature differences lead to everything, right? And overall, without solar energy, there would be nothing at all that would exist in the entire solar system. So main source of energy for Earth's atmosphere and weather systems is the solar energy. Is that clear? Okay. Let's go on to the next. Consider the following statements. Water vapor is a static gas and increases with altitude. Water vapor is the most potent greenhouse gas. Cow is the source of water vapor, and transpiration can impact quantity of water vapor in the atmosphere. How many of the given statements is or are correct? So basically, water vapor is the biggest contributor to global warming. You will be surprised to know this, but water vapor traps heat. How does global warming happen? See, there is this greenhouse effect that is created. This is the earth, and this is the earth's atmosphere. Okay. Now, when incoming solar radiation is coming to the earth, the incoming solar radiation is coming in the form of UV rays, and this atmosphere is transparent to UV rays, the ultraviolet rays. Okay, so UV rays come directly to the ground and they don't heat the ground. It is actually the infrared rays, the UV rays which are reflected back from the ground, which are in the form of infrared rays. Here you see, these are the ones that are trapped by the atmosphere. Okay, the infrared rays are trapped by the atmosphere and they heat up the environment, they heat up the overall earth. So we have to see that which gases formulate the atmosphere and which gases hold these infrared rays more. So water vapor, that is H2O, in the environment, it does not hold a lot of energy. It does not hold a lot of infrared rays. But because of the quantity of water vapor being the highest, the quantity of water vapor is the highest, and that is why it is the most potent greenhouse gas. Okay. We talk about carbon dioxide being a greenhouse gas. We talk about methane. We talk about all of these gases. But actually, it is the amount of water vapor that when it increases, it holds more infrared rays and it leads to the heating of the earth. So second is correct, but water vapor is not a static gas. It is a very variable gas. Okay, it is a very variable gas because the moisture content can increase also, can decrease also according to the season. So it's not a static thing. I'll give you an example. Ozone. Ozone is a static atmospheric component, right? Ozone does not get impacted by seasonality. Ozone does not get impacted by temperature, right? Now you might say that ozone is killed off because of the chlorofluorocarbons, etc. But that is an anthropogenic reason, right? Overall, ozone is not impacted. So ozone is a static gas. But water vapor, it's not a static gas and it does not increase with altitude also. The higher you go up the atmosphere, the lesser will be the water vapor. So it decreases with altitude. So first is absolutely incorrect. Then water vapor is the most potent greenhouse gas, correct. Cow is the source of water vapor. Yes, every living organism is the source of water vapor. Every living organism is also a source of methane. We'll talk about it. Then transpiration can impact the quantity of water vapor in the atmosphere. Absolutely. Transpiration is the release of water. It's the release of water by plants. Okay? Transpiration is the release of water by plants. And of course, it will impact the water vapor in the atmosphere. So here, only 3 is the correct answer. And water vapor is not a static gas. It does decrease with altitude. Fine. I hope you understand. And how I hope this is clear to you that how atmosphere is heated. Because इस पे सवाल आए हैं. अच्छा, another thing, that when the radiation is incoming from the side of the sun, when the radiation is incoming, it is called short wave radiation. Short wave radiation, because the energy is so high that the wavelength is not very huge, because it has to move very faster. So solar energy, the UV rays, they are very high on energy, and that's why they are short wave. But when they are reflected by the earth's surface, they become long wave. When they are reflected by the earth's surface, they become long wave, and infrared is actually a long wave. It has lesser energy than the UV, but it is more. The atmosphere traps it more. Okay? So here, please remember the difference between long wave and short wave also. Incoming solar radiation is short wave. Outgoing radiation is long wave. Alright, next question. Which of the following pair is not correctly matched? Atmospheric layers and characteristic. Troposphere, mesosphere, thermosphere, ionosphere. So यहाँ पर हमेशा याद रखना है that all the biological activities that happen in the atmosphere happen in the troposphere itself. ठीक है, so troposphere biological activity absolutely correct. It is the bottommost layer of the atmosphere and it has the all the biological activity that exists. Above troposphere, it is only the gases that exist. ठीक है, so first is correctly matched, so it will not be the right answer for this. Mesosphere, ozone. Mesosphere does not have ozone. It is actually the stratosphere which has ozone. Stratosphere is the second layer from the ground. Troposphere is the first layer. Stratosphere is the layer above troposphere, and it has the ozone layer in it. Fine. So this is incorrectly matched. Then thermosphere, radio wave transmission. This is absolutely correct, that thermosphere will be having the radio wave transmission. It is the second last layer. So if I were to draw here, this is troposphere, this is stratosphere, this is mesosphere, then this is thermosphere, and then this is exosphere, and this exosphere gradually meets with the space itself. ठीक है, तो ये चीज याद रखना. Now here I also want to tell you that within this thermosphere there is a layer in the lower thermosphere which is called ionosphere. And this ionosphere, what is an ion? Ion is a charged particle. So ionosphere has a layer of charged particles, and that layer is present in the thermosphere itself. So D is correctly matched, and it's because of the ionosphere and the interaction of sun's flares with the ionosphere that we see the auroras of the Earth and the atmosphere. Aurora borealis, aureola australis. Now, so here the answer is B. Now I want to tell you some crucial features of each atmospheric layer. So please just know that why, and these are very crucial details. Okay, I'll explain them to you very casually, very simply, but these are very crucial details. So troposphere, stratosphere, then we have mesosphere, then we have thermosphere, and then we have exosphere. So let's see, this is troposphere. Troposphere में the higher you go, the lower your temperature, the temperature of the atmosphere will get. So temperature decreases with altitude. Temperature decreases with altitude. ठीक है, ये चीज clear हो गई. Come to the next layer. Next layer is stratosphere. Now here it becomes opposite. Because it has the ozone layer, that is why ozone absorbs the UV radiation, and that is why the higher you go, the temperature increases with altitude. Fine. Generally, this is an anomaly, because when you go away from the ground, as you go on higher in the, higher above, the temperature is supposed to decrease, right? But in the stratosphere, because of the presence of ozone and because the ozone has absorbed the UV radiations, so it will rise, the temperature will rise. So this is very important. Then there is mesosphere. Mesosphere, the word comes from middle. Meso means middle, and mesosphere because it is the middle layer, 2 layers above it, 2 layers below it. And here again, because it does not have any special feature, here again the temperature will decrease with altitude. ठीक है, नेचर में यही होता है that temperature decreases with altitude only. The higher you go in height, temperature will decrease. But it's an anomaly here. Now, this is thermosphere. And thermo itself means temperature, heat, right? And thermosphere has a layer of ions, which is ionosphere. So thermosphere इसका नाम इसीलिए ही पड़ा है because here also temperature increases with altitude. ठीक है? Temperature increases with altitude because of the ionosphere. Right, it increases in the temperature increases with altitude, and then there is exosphere which gradually merges. So exosphere mein the temperature again decreases. Okay, so I hope this is very clear. And the crucial features of, so for example, where do flights fly? Flights fly in lower stratosphere where there are no clouds etc. ठीक है, तो ये करेंगे धीरे धीरे करके आगे जाके. Next, what is the main reason for the high temperatures in the thermosphere? Intense solar radiation, intense greenhouse gas in the atmosphere, absorption of cosmic rays from space, or residual heat, residual geothermal heat from Earth's interior. So, what is the main reason? See, I told you there is a layer called ionosphere in thermosphere, right? And that is subjected to intense solar radiation, which is because it has high temperature. ठीक है, एक तो electrically charged ions हैं उसमें, because of which the whole aurora borealis and australis are happening. तो ये now increase greenhouse gas in the atmosphere का impact कहाँ पड़ेगा? Impact इनका पड़ेगा troposphere पे. Greenhouse gases का impact, because the biological activity is in troposphere, the impact of the greenhouse gas will also be in the troposphere. Fine. Then the third one, absorption of cosmic rays. No, cosmic rays is a very broad term. Cosmic rays में कुछ भी हो सकता है. It can be gravitational waves also. It can be so many things. So ये बहुत ही एक vague term है. So that's why not relevant. And residual geothermal heat. अगर इससे heat करना होता geothermal heat से, तो the lower layers of the atmosphere would have heated, right? So here A is the correct answer. ठीक है, चलो. You have to always choose the best possible answer, the most suitable answer according to according to the question that has been asked. So अगर ionosphere से related कोई option होता, you would have chosen that. But because that was not there, you have to apply your brain and see that which option fits the best. Okay, consider the following gases. How many of the above gases are transparent to the incoming solar radiation and opaque to the outgoing terrestrial radiation? Oxygen, nitrogen, helium, or carbon dioxide. Basically, what they are asking you is that which one of the following is a greenhouse gas. That's what they're asking you. So now please be very careful here that it is written nitrogen. It is not written nitrogen dioxide. Nitrogen dioxide or nitrogen oxide is actually a greenhouse gas, but nitrogen in itself is the most potent gas. It's the most 70% of our atmosphere is nitrogen, right? But it is not reactive nitrogen. It is non-reactive nitrogen. So it is transparent to the, it is not transparent to the incoming solar radiation. It is just carbon dioxide, which is transparent to the solar radiation incoming, but it is opaque to the outgoing radiation, which leads to the greenhouse gas effect. How will you arrive at this answer? You will arrive at this answer by knowing that what is the whole proposition of the entire atmosphere, right? Nitrogen has the highest quantity. Then there is oxygen, about 21% oxygen is there. Then helium is there, but they don't trap the outgoing terrestrial radiation, right? So that is important. Here only one. Whenever they are asking you that incoming solar radiation के लिए transparent and outgoing के लिए opaque, they are asking you about the greenhouse gases. Fine. So here only one is the correct answer. Next, consider the following statements. Temperature rises as one goes from bottom to top in the stratosphere. Temperature decreases as one goes from top to bottom in the mesosphere. Which of the above statements is or are correct? So ये मैंने आपको अभी भी बताया है कि when stratosphere has ozone, so that's why the temperature will increase going from bottom to top. So this is correct. And temperature decreases from top to bottom in mesosphere. No, it decreases from bottom to top, like generally the temperature behaves. So here second statement is incorrect, first is correct, so A is the answer. Please be very careful because ऊपर वाले में bottom to top लिखा था, you might be lured into thinking कि यहाँ पे भी bottom to top का ही पूछ रहे होंगे आपको, but that is why each and every word that is written in a question is very important so that you are able to assess that what the question is actually asking you. So A here is the correct answer. Next, consider the following statements. Height of the tropopause is more above the poles. Height of the tropopause varies with the season. It acts as a lid to tropopause weather phenomena, and there is a presence of jet streams in tropopause. How many of the above statements is or are correct? So basically, what is tropopause? Tropopause is like the lid of this troposphere layer, है ना? And all the biological activity happens in the troposphere only. So tropopause is like a lid to that whole biological activity. Now, let's say this is the earth, and please visualize this is the equator, this is north pole, this is south pole. Okay, now what have I done? I have shown you the earth laterally. When you are on the top, when you are watching from the equator side, the heat that is there at the equator, that is the solar, the insolation at the equator is much more as compared to the poles. So the gases will rise more. When the gases get heated up, they rise more, right? And that is why the length of the tropopause, overall the width of the troposphere will be maximum above the pole, above the equator, and it will be minimum above the poles. Are you understanding? Because of insolation, and that's why we say that solar radiation is the biggest determinant of all the atmospheric activity. Because of the solar radiation being maximum at the equator, and it's not maximum at the equator, it's maximum at the tropics, we'll talk about it, but overall the radiation is more at the equator side, which will lead to the gases moving upwards, and the height of the troposphere will reach somewhere about 10 kilometers from the ground. 10 kilometers from the ground. But this polar side, the height of the troposphere will be hardly 4 kilometers. Okay, from the ground to the top. So this is the whole difference that is there. And so height of the tropopause is more above the poles is incorrect. Height of the tropopause is more above the equator. I hope you understand that. Then height of the tropopause varies with season. Yes, during the summer season, height of the tropopause will be higher because of the exact same reason that I told you, that heat will lead to the upward movement of the gases. Then it acts as a lid to the troposphere weather phenomena, absolutely. And there is a presence of jet streams in tropopause, yes. Jet streams are high altitude wind systems, and we'll talk about them when we talk about this climatology. But jet streams are very important to understand how the surface level winds are also functioning. So for example, let's say winds like Lu, if they are functioning here at the surface level, jet streams are functioning at the level of the tropopause. So they are happening at the higher altitude. Okay, so these three statements are correct. Only three here are correct. One is incorrect. I hope you understand. And I hope you understand the concept of tropopause also. Fine. Next. Consider the following gases. How many of the above gases were in abundance at the time of evolution of the solar system? Oxygen, nitrogen, helium, hydrogen. So हमें देखना है, we have to start with the whole formation, that how we were formed actually, and we were formed apparently according to the current descriptions, we were formed from a part of the sun only. We were a part of the sun only, and sun is made up of hydrogen and helium, right? So hydrogen and helium were aplenty in our early atmosphere. but oxygen and nitrogen were nowhere to be found. The living organisms eventually changed the entire structure of the atmosphere, and they created oxygen, and nitrogen was eventually added. So here only 2 is the correct answer. Even carbon dioxide came very late, right? It was initially helium and hydrogen. Next, consider the following statements. The ionosphere F layer is the bottommost layer, and the F layer consists of low electron density. So here, see, the ionosphere is in which layer? It is in the thermosphere, right? It is in the thermosphere. So, and I think in the last question mentioned regarding this, I mentioned that ionosphere is in the bottom. No, ionosphere is towards the top actually. The ozone layer is towards the middle and the bottom of the stratosphere. So if this is the ionosphere, the layer which is there where the ionosphere is called the F layer, and F layer is the topmost, is the basically the uppermost layer of the thermosphere itself, and it has high electron density. Okay, so here both the statements are incorrect. Within the ionosphere also, it is important to know that the topmost layer, which is called the F layer, it has the high electron density, and it is actually called the ionosphere within the thermosphere. Fine. So that is all for atmosphere. I am telling you, this is one of the most important topics of geography. You will be getting a question every year from this, not even every other year. So I would highly recommend that you go to class 11th physical geography of the world and you study this atmosphere chapter from there. And if you are following the Sunya books, just study the atmosphere chapter from Sunya book. And if you have your own notes, even that is fine. Make sure your notes are updated. Okay? So that is all for today's class. What we are going to do in the next class is about the heat balance, the solar radiation, the overall temperature difference of the earth and its layers. Fine. So I'll see you all in the next class. Please do not forget to complete your homework, and yes, take care. All the very best. Bye bye.